And again, this was the last one we did the other day. Remember, you always got to reduce it. And you remember on complex numbers, you must put it in A plus BI form for your final answer. So you can't leave it over a common denominator like that. Okay, you have to split it out here. And in this case, do some simplification before you go on. Just a brief moment of review there of where we kind of left off. Okay, here are some problems that we do. Simplify, write in A plus BI. Well, we'll do this one right here. What's square root of negative 49? 7i. So the answer would just simply be 4 plus 7 in that order. Okay, this one, it would be 3/7 minus 8/7 I. Because you can't leave it under that common denominator. This one, again, we'd have to break the 20 out underneath it, deal with the 75. So 10 plus radical negative 75 over 20. We got 10 and plus, okay, 75 breaks down into 25 times 3. And then we've got the I out there, right? I've extracted this I all over 20. So 10 plus 5i radical 3 over 20. But now we've got to get rid of that common denominator. So 10 over 20 plus 5i radical 3 over. And we can do a little bit of reducing. Reduce it to 1/2. 5 goes into 5 once, into 24 times. So we end up then ultimately with 1/2 plus I radical 3 over 4, or 1/2 plus radical 3 I over 4. We actually accept this one, even though it doesn't perfectly fit the A plus BI, because sometimes if you get a little careless, it might look like it's under the cap. So if you write it this way, and this is the ideal way, and in fact, Alex may give you business about this way or that way. You're going to have to play its game. Be sure there's no question that this I is underneath that radical. Okay. Oh, I know what that humming sound is. Is the parking lot guys. Okay, powers of I. Might look at this. Whether you write it down or not, I don't care. We're going to figure out how to get them. Now, you notice in all instances, the answer is either I, negative I, 1, or negative 1. In every instance, isn't it? It's one of those 4. Well, there is a procedure we use to convert these powers into whatever number it is. So let's deal with some of those. Here I have the first one worked already completely. I to the 13th. Now, I don't know why in the world you would ever have that value, but we need to know how to deal with it. Okay? What you do is you break it down into an even power to an odd power, because there's a hidden first power behind this one. Okay, there's a hidden first power behind anything that doesn't have a power shown. So we had an even one and an odd one, and the biggest even one you can. Now, the reason we go with this even one is because then we can change this even power to I squares to half of whatever that even number was. And I squares are in turn equal to -1, which we can take to this power, which will tell us whether it's either a positive or a -1, depending on the numbers. Okay, this one just kind of trails around down to the end in this case, and 1 times I is I. So what is our process? This is the same process we're using every problem of this time. Get an even power of I. Now, if you have to pull one of them out to do that, you do. Some you will, some you won't. Okay. Second step, convert that even power into I squares to half that even power. Then replace the I square with -1 and finish evaluating. Let's look at another one. Okay, I to the 18th. This one's already an even power. Okay. So I don't need to pull that 1 out. That's only on odd powers. So here I've already got an even power. So I break it down into I squares to the half of what it was. Well, I squared is -1 again. -1 to the 9th power. Okay, what's a negative to an odd power? A negative. What's a negative to an even power? A positive. And we're going to use that little shortcut here. So -1 to the 9th would give us -1 overall. Isn't this thing going on? Battery dead? There we go. Okay, I to the 32nd. Once again, we have an even power. Okay, so in this case, we break it down into I to the 2nd times 16, half of that power. Okay. Replace the I square with -1. -1 to an even power is +1 and done. Now we've got some more. I want you to do these. You do these. Okay, just so you don't get stuck and sit there. The first step on this one, where you've got I to the 45th, is to make it into I to the 44th times I to the hidden first. Go ahead and do all 4 of them. Okay. I made it into I squared to half of that power. Now, -1 to the 22nd times I. That's an even power, so this is going to give me a +1 here. And I, so it's just simply I. Okay. Okay, here's number 9. Anyone need to see number 9 work? Okay, let's try it again. Anyone need to see that one work? Okay. So, I to the 31st, that's an odd power, so we break this down into I to the 30th times I to the 1st. Then this I to the 30th, we break down into I squared to the 15th times this I to the 1st. Well, we replace the I squared with -1 to the 15th times I. And -1 to an odd power is going to be -1 times I. So the answer is -I. Okay. Let's do number 11. Anyone need to see that one done? I guess we can go on. That brings us to the definition of a complex number. All of this you've seen before, okay? And they're going to tell you if B is 0, then there really is no imaginary part and it's just a real number. If B is anything different than 0, then it is an imaginary number. Complex number is written in standard form. In other words, you got to have a number plus or minus that. Now, if A is 0, then you're just going to have something like 3i or -1i. Okay. Now, the operations, addition. Pretty simple. What would you do if you had 16 minus 3x plus -3 plus 5x? Well, you would add variables with variables and you would add numbers with numbers, wouldn't you? Same thing. I performs 2 roles. It performs the role as an identifier for an imaginary number, and it also behaves like a variable. Okay, so we're simply going to numbers with numbers, eyes with eyes. Okay, we're going to combine these two, combine those two, end up with this, and it's got to be in that order, can't be reversed. Okay, pretty simple on that, right? That's just addition. Subtraction. Ooh, I got a minus in the middle. Well, I bring down this one just like it is. And here I've got to distribute this negative. Negative times negative is positive. Negative times positive is negative. So I take this here and I take it there to get rid of that minus in the middle. Okay, now I do it just like I did the one above. Eyes with eyes, numbers with numbers, and that's what I get. Any questions so far on any part of this? Okay. And here's just some more. Do I really need to work these? Okay. Again, the rules. We're dealing with multiplication now. Here I'm going to take negative 4i and I'm going to what? Distribute it, Rocky Mountain High, to both of these terms. When I do that, negative 4i times 3 is negative 12i. Negative 4i times negative 2i is positive 8i. And the negatives cancel each other out. So I got this business. Well, I can't leave it that way because I can replace this I squared with a negative 1. If you can, you must. Always. Okay? By the way, not doing that is a major mistake, -2. Okay? So anyway, we replace this I squared with negative 1. So that's going to make this negative 8. But we can't leave it in this order. We've got to put it in a plus bi. So the final answer then is negative 8 minus negative 12i. Questions? Okay. That was pretty simple too, wasn't it? Let's look at another one a little more complicated. Let's do some binomial. Now, oddly enough, I haven't taught you binomial multiplication yet, but they assume in this class you know it. Okay? That should be a previously attained skill in this class. Well, there's a couple of ways you can do it. You can do it the old FOIL kinds of ways. All right? You know, first, last, inside, outside. Draw the little thing that comes out looking like a face. But the mathematics easy for me to say. The mathematics department has asked college algebra teachers not to teach the FOIL method because later on in calculus, it will not serve you well. They want us to teach you and just go by the distribution method, or if you please, double distribution. So what we're saying is we're going to take this number and distribute it here and here. And when we do that, we're going to get 4 times 3 is 12. And then we're going to get 4 times 2i is plus, in this case, 8i. And we're going to distribute by this number. Here and here. I can't write on my tape, so I can't make mountains of it, I guess. So anyway, I take negative 5i times 3. That gives me negative 15i. Notice I'm lining up my i's. Okay. And then I'm going to take negative 5i times positive 2i, which gives me negative 10i squared. 90% of the mistakes on this problem is you leave off that square. That's the most common error on this particular problem. Okay, and then that messes you up from there down if you leave that off. Okay, so we combine like terms and we got 12 minus 7i minus 10i squared. Well, we got to replace this I squared with negative 1, right? I'm showing you a lazy way of replacing it. Lazy way of replacing it instead of rewriting the whole line. So 12 minus 7i plus 10. Combine the 12 and the 10, get 22 minus 7i, done. All right, any question on this one? No? Okay. We'll leave that up there for just a moment. I think they're going to work this problem down. Okay, here they did their distribution. Okay. Here, there. Okay, and then they're going to combine like terms. And they've already replaced the I square with -1. But I wanted to physically show that it's there. And so then they got the same line I got here and the same answer I got. Okay. Oh, better erase this stuff up here too. Do I need to show these? Anyone want to see either one of those work? No heads nodding this way. Okay. Uh-oh. A binomial square. There's actually a shortcut we're going to take on this one. Or we could take on this one. But I'm not ready to show you the shortcut yet. So we're going to do this one the long way. This one we're just going to say, we're going to make this thing into 6 minus 7i times 6 minus 7i. Well, we're going to work it the same way as last time, okay? There's the shot. Whoops, back up. Too far. Well, this thing's got a hair trigger on it. There is the shortcut. If you look on page 10 at rule B, this way. If you look at page 10 on rule B, that's the shortcut. Now, what that says is when you've got a binomial square, there is a rule that it will always come out a certain way. Okay? And that certain way is when you multiply it out, and I'm going to prove it with this way in a few moments. When you multiply it out, you're going to get whatever the first term is, in this case 6, squared, or in other words, 36, right? In the middle, you're going to have, because that's a minus, and this is a minus, if that was a plus, this would be a plus, 2 times the 6 times the 7i. You might wonder why, and I'm about to show you in a moment. And then you would have the last arm, the 7i squared, which in this case would be 49i squared. Okay? Now, I think I'm going to go ahead and work this one. I wanted to see where they're going to do some work. So, 6 times 6, 36. Okay? 6 times -7i is -42i. 7i times 6 is another -42i. That's where the 2 came from. Because there are 2 of them. 2 of those 6 times 7i's. Plus 7i times 7i, or -7i times -7i is positive 49i squared. Okay, if I add this together, 36 minus 84i plus 49i squared. Now, eventually I got to deal with this thing, okay? But right now I'm just kind of trying to show you how that thing up there, that shortcut, works. And why that 2 is there. Well, to finish this thing now, 36 minus 84i let's do our replacement, minus 49. 49 minus 36 minus 49 is negative, I don't know what, 13? Check me. Okay. Minus 84i, done. Okay. Ultimately, they did it the way I did. But you could have done it, you could have did it using that shortcut and get the same thing. First term squared, 6 squared is 36. Okay. First term times last term, 6 times that's negative 42i, times 2 is negative 84i. And then last term, negative 7i squared is negative, is positive 49i squared. So you could have done it either way. Now, this rule B shortcut, when we get into factoring in a little bit, it can go either that way too. Because it's a squared minus b squares, or a minus b squared, factoring of an equation in that form. Okay, so it goes either way, factor or unfactor, factor or multiply. Okay. This one. This is an example of rule C. Look at rule C. Rule C says that anytime you have this times that, the only thing that's different is you got a minus here and a plus there. Okay. Same value, same first term, same last term, opposite signs. Okay. By the way, that has a name for that format. It's called conjugate. C-O-N-G-U-G-A-T-E. And you will hear me use that word throughout the remainder of the semester. Okay. Anyway, if you multiply conjugates, you're going to end up with this format of an answer. Okay. Or in this particular case, a squared is 4, b squared is 25i squared with a minus in the middle. So 4 minus 25i squared, and then you convert the I squared. Okay. Now, I gotta tell you a story. True story. My first year of teaching. My first time I ever taught about conjugates. I threw this problem, or one like it, up on the board, and we were using blackboards in those days, back in the dark ages, literally in the 70s, okay, more than 50 some odd years ago. And I've had my head filled with educational nonsense about, oh, you should always start a new topic by the questioning method to find out what the students know about the topic before you begin. Well, that sounds good. But in this case, it kind of backfired. I just stepped there at the front of the class all proud and confident. Remember, first year of teaching. Okay. And I also weighed about 75 pounds less than I do now, but that's irrelevant. And I asked, anybody know what a conjugate is? This little girl in the back of the room raised her hand. Yes, what's a conjugate? Oh, I was so excited. Is that when my mama goes to visit my daddy? True story. Oh. I didn't literally scream, but that's spelled different. That's conjugal, but we'll not talk about that. And then I explained this then. Now I always explain this first. Okay? Sometimes we learn by our mistakes. And I tell you what, I bet that little story I just now told you will cause you to never forget this. Okay, so it served its purpose in that way, but that is a true story. Okay, well, let's go on. First term squared minus last term squared gives you that. Convert the I. And look what happens. The I's completely go away. How cool is that? Now, knowing this fact that that will happen, and it will always happen. Okay? Knowing this fact is going to help us in division problems where you can't ever have an imaginary in the denominator in your final answer. Okay? Please put the calculator away, or the phone rather. If it's that important, take it out and then come back. Okay, now, I haven't proved to you that this thing is true or why the middle drops out. So I want to take just one more moment over here to see if we really believe this stuff. When we multiply this out this way, 2 minus 5i and 2 plus 5i, and we distribute it, 2 times 2 is 4. Okay, 2 times this is positive 10i. There. Now I've got it correct. Now let's go to this one. Negative 5i times 2 is negative 10i. And negative 5i times positive 5i is negative 25i squared. What happens to these two? They go away. That's why there's nothing in the middle on this one. They will always cancel each other out there. And this one will always convert that I squared to a negative. Okay, so this is the standard method of getting rid of i's in the denominators of problems. Now, we don't care if they're in the numerators, but in the denominator, thou shalt not have them there. Okay. Again, all conjugates. The product of complex conjugates is always going to be a real number. All the i's will drop out. That's all that's saying. Okay, because those middle terms will be opposites and cancel. Okay, here's an example where we would really use this. this division problem. I got i's in the denominator. I can't have that. How do I get rid of those i's in the denominator? Well, what I do is I take it times 2 minus 6i, its conjugate, over 2 minus 6i. And I also put parentheses around these. You see these two are conjugates, right? Those two are conjugates. What's going to happen with those two? Let's just those two. I'm going to get 4 minus 36i squared, which is going to be 4 plus 36 when I do that, which is going to be 40. No more i's in the denominator. All I've worked is the denominator so far. Then I still got to work the numerators. Now they can get nasty. This one I just have to distribute here and there. So that gives me, okay, this one times that, this one times that is negative, positive 12i. Duh. Now, this times that is what? 14i. And this times that, negative 42i squared. This one isn't going to be a conjugate. We're not going to have a middle dropout. Okay? So what have we got when we combine all this stuff? We got negative 4. We've got 26i. And we've got negative 42i squared. Okay, replace this with a negative 1. And we've got negative 4 plus 26i plus 42. Bring this over. Gives us 42 and negative 4 makes positive 38 plus 26i over 40. 38 over 40 plus 26i over 40. Both of these will reduce. Okay. 2 goes into this one 19 times. 2 goes into that 20 times. Plus 2 goes into this 13 times I. And 20 again. And that would be your solution. Okay. Like I said, the numerators can get nasty. But boy, don't the denominators go nice. Okay. But this is the standard method for dealing with an imaginary in the denominator. Okay. You multiply it by its conjugate. Okay. And that's the always rule. Well, I made some mistakes on that, but you know what? Mistakes before I finished it. And hopefully you're going to get where you do that too. As you see, it works out the same. All right. One more of these, then we're going to go on. Multiply by the conjugate. Distribute the numerators, use the shortcut on the denominators. Okay, anyone not ready for me to go on? Yeah, I see at least one person isn't. You ready? Okay, we're gonna skip that. This one, in this case, you just need to multiply it by I over I because we don't have the A plus up here. That one's a little easier. So you get I squared becomes -1, and you've gotten rid of it. You could multiply it by -4i if you wanted to, which would be the conjugate of that. Here's another one. We're gonna not deal with that right now. Okay, that's not part of our concerns. We need to get into factoring. Okay, just read this, don't write it down. Okay. Given this standard form for a quadratic equation, a quadratic equation is an equation that makes an arch, the golden arches, if you please. Okay, or a jump rope. You hold the two ends of a rope or a chain, it's going to make a perfect parabola. Okay, they're called quadratic equations, they're called parabolas. Same. Now, if this C value is positive, then when you factor this thing, both signs in the middle of your factor terms, A plus B, would be A plus B, A plus B, or A minus B, A minus B. Okay? In other words, if that's positive, both of them are going to have the same sign in the middle of this thing. Either both positives or both negatives. If C is a negative number, then when you factor this thing, one of your factors has to be positive and one of your factors has to be negative. If you look at page 9, you right up at the top, you can see this. Okay. If C is a positive number, or if both of these are positive, then you're going to have a positive. If you've got this, that one's minus, but the C is still positive, you're both going to have the same sign, but they'll both be negative. Okay? Now, what if C is negative? Then one of them is going to be positive and one of them is going to be negative. That's the most important thing for you to know about factoring, because then you can figure out the form of your answer. Okay? Now, when I went to high school and actually in college too, about the only way they taught factoring was the by guess and by golly method. You know, you try some numbers and see if you get a right answer, and it can become an infinitely long process. And I absolutely abhorred factoring. Well, many years ago while teaching, because I was so disgusted with the way I had been taught, I looked for a way, and I came up with this way. And this way has been published in a high school textbook quite a few years ago. It has one part of it that's a little hard to explain, so it's not widely. You'll see the AB method. Any of you taught the AB method, or AC method rather, of factoring in high school or college? Parts of this are the same, but it keeps it much more simple. Okay. Now, here are my rules for factoring. Obviously, you look if there's some common value you can factor out of all three terms. Okay, and if you can, you want to get those out of there because they just make it unnecessarily complicated. Second thing you do, you see if you have any like terms that can be combined. Basically, between these two, you're seeing how can you simplify this thing before you start working on it. Okay. Now, look at the rule of signs to determine what kind of an answer you're going to have. Then find what I call the multiple pairs of the first term and the multiple pairs of the last term. So far, we're just like the AC method. Okay? Except now I do a cross product of these multiple terms. And it will produce the middle term, which you can verify. And if it verifies, then you've got it factored. So let's try an example. Whoops. Okay. Factor by my method. Again, this is not the best, but here's the original equation. The multiple pairs of my first term are 1 and 2. They're the only numbers that'll go. Don't write this one down. Okay, we'll get better ones. The multiple pairs of that are 6 times 1, 3 times 2, 2 times 3, 1 times 6. Those are the only possible sets of numbers that could go here and here and here and here. Those factors of 6 are the only numbers that can go in those two places in your pairs. Those two factors of 2 are the only numbers that can go in here. One of these better be a 2 and one of those better be a 1 in this case. And we got to figure out which one of these go in there and there. Okay, that's the understanding on how this thing works. Now, here's some problems let's deal with. Let's look at number 1. X squared plus 8x plus 15. X squared plus 8x plus 15. In this case, my multiple pairs, the only choice I have are 1 and 1, right? Because there's a hidden 1 in front of here. Over here, I've got the possibility of 15 times 1. I've got the possibility of 5 times 3. Those are the only possible combinations of numbers that will multiply to get 15. Okay? Now then, this one's easy. I'm just going to put them down. These are my multiple pairs I talked about a moment ago. Now, I'm going to talk about the cross product thing that I do. I bring down the only multiple pair that I have here. Here, I've got to decide what do I put here. So if I multiply this number times that one and this one times that one, I end up with an 8 in this case where I add them. Why do I add them? Because these have the same sign. Remember that first slide I showed you and I said if C is positive, they both have the same sign? What are the rules of integers? Same signs you add. If C had been negative, then I would have a minus here. Different signs you subtract. Okay? Now, I want to end up with two numbers added together that make 8. Are any of these combinations? Well, if I put the 5 and the 3 here, 5 times 1 is 5. 1 times 3 is 3. 5 plus 3 is 8. We have just verified the middle. So look at this. Look at this. Let's put a parentheses there and put our X in here. And because these have both got to be positive, and we'll talk about when it's different in just a moment, here are my two factors. x plus 5 times x plus 3. Isn't that kind of logical? Okay. It's time. Anyone like to see one more? Okay. I would have done this one, but it's just like that one, except both signs are going to be minus. Okay. And I have same signs, so down here I would have a plus still. So the one that I want to do is one of these where I have a minus c value. Okay. I'm going to leave this here for comparison. All right, so let me grab a pen. And y squared minus y minus 20. Looking at this problem, my final answer better look like y plus something, y minus something. I know it's going to be 1y because I've only got a 1 here. Okay, so 1 and 1, 1 times 1 is my only possible factors there. Over here, I've got 20 times 1. I've got 5 times 4. And I've got 10 times 2 are the possible multiple pairs. Now, when I get down here at the bottom this time, because I've got different signs here, according to that rule of C, I'm going to subtract my cross products. Okay? So, since these are 1s, this one's pretty easy. I need to get a 1 here, a 1. Which one of these sets of pairs, if you subtracted them, would give you a 1? 5 and 4, wouldn't it? So 5 and 4 is what goes here. Multiply it, 5. Multiply it, 4. 5 minus 4 is 1. That confirms that number. But now we've got to verify the sign to know whether the 5 goes with a plus or whether the 5 goes with a minus. And here's how you do that. This 1 has to be a minus, right? We subtracted. Let's go back to the rule of integers. When you've got these, you take the sign of the biggest. Remember that? So the biggest one is this one. So this negative sign's got to go with that 5. So you got -5 and 4 makes 1. So anyhow, this sign always goes up here to the top. This sign, which is positive, always goes here on the bottom. So that means that my answer is x minus 5 and y plus 4. Okay. Now, bad news. Turn to, I think it's page 39 in your packet. And we're going to do some more of these on next Tuesday, Monday, next Monday. Oh, no, we won't. Next Monday is Labor Day. Yay! Party! No class Monday. Don't come. Won't be here. This so you can get a head start if you wish. You're going to have an offline assignment. An assignment that's done on pencil and paper and turned in. Page 34, excuse me. Page 34. And it says this in my pacing guide, by the way. This page 34, 35, 36, 37 is an assignment. Now, there are only certain numbers of this that you're supposed to do. Okay? And somewhere I think I've got those numbers listed for you. If I don't, and I don't, I will have those listed in Blackboard by sometime today. Which ones? Because out of the 108 problems or so that are in here, you're only going to do like 45 of them, I think. Okay. I'll get those up there. If you want to get a head start on it, you can. There are multiple kinds of factoring in here, all of which we will eventually cover, but we made a start. Okay. If you want to use your old style method, you can. I think this method that I'm showing you will be faster in most cases. Okay. With that, have a great weekend.